So, with that, I switch now to German because I will now give my presentation, and most of you are German, so but I have English pictures. And my name is Jan Wörner, as I said, and I'm the chairman of the executive board of DLR and at the same time member of the board of Forum Flughafen und Region. Meine sehr verehrten Damen und Herren.
Ladies and gentlemen, now I would like to take you into the different aspects of possibilities we have. And I do that on the basis that we agreed upon in Frankfurt. That is the mediation package. The mediation package is here. It used to be the basis and will continue to be the basis, and it has these 5 points that are equally important. Just to understand in what function I'm talking to you, let me briefly talk about the group or the center that I am talking on behalf of. DLR carries out research in the area of aviation, aeronautic research and technology, and we are also project organizer for German research in aviation and avionics. So every research that is carried out on behalf of the federal government is administered by us, not decided, but administered, managed by us. And therefore, the DLR has a very important task in positioning research projects. If you take a look at avionics, like in many other areas, you have the so-called technology readiness level. This is meant to describe how far a technology has matured, how far it has been placed in the market. I just turn this picture around to make it simpler, and I will transfer it into a different picture where you can see from the left to the right-hand side basic research towards market. So you can see it presented only in a different way. Technology level 0, and then the highest level, the technology readiness level. And here there are different disciplines. And here you also find the DLR. The DLR really tries to close this chain to have a seamless chain of innovation from basic research towards development. What does it has to do with today? Many ideas that we have really start with basic research until they found their way into the market. We heard it from Mr. Boddenberger. Well, till they find their way into the market, it really takes a bit longer than only 3 to 5 years. Sometimes it takes even 20 years. And it's important that at the beginning of the chain, we never stop thinking about it. We might say we know how an aircraft looks like. It has 2 wings, and it has a landing gear, a powertrain. That's what you need. But then we probably miss chances, and therefore disruptive ideas need to be given a chance to be supported and financed. Of course, as chairperson of this large research center, I have to say that sometimes there are insane ideas that question probably everything, and everyone is shocked and says, no, for goodness, now our beautiful aircraft is put upside down. DLR works in the area aviation, aeronautics, air traffic and air control and safety. And we also try to create some cross links. Oftentimes, more often than you might think, there are areas that we take from another discipline and take into a different discipline once again and take it then back to that area, like from musics into air noise. That might be strange, but I show you in a minute. The DLR has a separate research fleet, and we modify aircrafts and test things before they can enter the market. So we can test things far before, and we can see whether there is an effect. Now talking about air noise, and you'll see more aircraft today, especially my colleagues from the DLR. No wonder I got the pictures from them. So that's the chance of the boss, to just take pictures of colleagues. You can see everywhere you have areas of a plane, of a traditional, conventional plane that produce noise. And every area needs to be looked at with keen interest. Okay, we have achieved already something. You have to consider that. That's the development of noise. That was a Comet, probably you know it, and an Airbus A380. And we really reached a lot. But the biggest danger for the future is the success of presence. You say, now we have achieved that and we can rest on our laurels. That would be the wrong way. We have to continue to work on that. Let me show you yet another example. Here you compare the 85 decibel for an Airbus 320. We heard some negative points about it before, and this is compared with a Boeing 727 for Frankfurt Airport. And I think you can't put it in a more impressive way, what we have achieved already. Now, if we take a closer look at the aircraft, there are different conditions. We have external conditions, we have the society, we have the airport, we have the aircraft as a separate system, and in the aircraft we have several subsystems and elements that we have to consider. And that brings me back to this mediation package. We've got the extension of the mediation package. We tried to optimize. We've got the regional dialogue forum. We carried it out. We also have the night flight ban. Some people might say it's not sufficient, but others says it's too much. But with the anti-noise pact, we still have some deficits, and therefore that's precisely the point that we have to dwell on in the future. And what we are discussing here today and tomorrow might be a chance to really determine it. It was the task of mediation to define an upper limit of noise. You can discuss about it. All right, if you take a look at that, growth goes on. I just put it here in a very simplified way. Most of all, I do it that way, but the advantage of simplified presentations is that they're easy to understood. So that would be the planning horizon for 2020, but the airport can do more than this horizon. There might be more aircrafts, and probably at one day we reach capacity limits. And then we could say, okay, not to have it even more noisy, let's limit the number of aircraft movements. There are a lot of rules and regulations for that, but would that reduce the noise? Because it doesn't determine anything about the noisiness of aircraft. And the air noise would grow, first of all, with the number of aircraft movements. The question is, what shall we do? Will we define noise as a decibel degree at a certain area or over certain regions, or would we consider only those that are annoyed most? And my favorite approach is the green one. This is the number of highly annoyed. That should be our central yardstick. But for that, we have to calculate that. We have the Frankfurt noise index that we developed. I don't want to go into detail here, but briefly, with aircraft movement, we get a distribution of noise in the region, and we know that a certain noise level has a certain impact and produces a certain number of highly annoyed. And when we take a look at the distribution of the population and the decibel figures, and if we link them, then we can come to a fixed index number of highly annoyed people in the region Frankfurt on the Main. And that's the Frankfurt Day Index. For the night index, there are different criteria. Just to simplify it, I don't want to talk about the night index. We have this index. We have a classification how noise can be quantified for the region. Quantified, not seeing the human being as an obstacle, Mr. Meisinger, but seeing the human being as the center of things, saying that the number of highly annoyed, that's our reference index, because this really considers the people. And if we have a look at another diagram, and it's simplified again, then this Frankfurt Day Index would grow with more aircraft movement, and at some stage the capacity is reached. And where are we now with our upper limit? As a result of the discussion of the past few years, it's relatively simple. This is where we had the starting point for the planning of the extension of the Frankfurt airport. And that was the point that was most logical and that can be determined most easily. Of course, now, such a determination from the point of the airport and the airlines, that creates unrest. Hopefully unrest. Let's say there might be such growth. We have a different development at the moment. All of a sudden you would say, no more aircrafts here. And that would be really cutting it a lot. That would be a strong interference based on noise annoyance, but is it reasonable? And for that, we have to see what the air traffic side can do, the strategic research can reach, but also airports and aircraft manufacturers. they have agreed on a paper, Flight Path 2050, and they have an innovation agenda of Icana. And on this paper that was also adopted by the federal office in charge, they say the perceived noise emission of flying aircraft is reduced by 65%. These are relative to the capabilities of typical new aircraft in the year 2000. Perceived noise emission. Well, this is just perceived, a perceived noise distribution emission. This is not precisely the same what I meant when I mentioned the noise index. There is one other point, but this statement is here. This is a statement of industry in the broadest sense of the word, and also of research centers, to do everything possible in order to have 35% of perceived noise. As a simple engineer, I've got the 100% line, and that is at 2000, and 35% by 2050 has the straight line. You can define it otherwise, but if you define it such a way, I don't believe it. If you say it that way, I said this is not the case. I know that, and therefore the straight line might be the easiest and most plausible one. And if we now combine it with the picture before, with the upper noise limit, we can see that there must be a bend. And once you've reached the capacity of the airport, then the noise limit, the noise level needs to go down. And this green area, that's our opportunity. Opportunity of airports, of airline companies, to generate growth with reduced noise in the future. These are just qualitative pictures, but the chance is there, and this is an important political statement. How can we reach that? We heard some points by Mr. Biesmann, different approach and departure path, but also quieter aircrafts. And we do everything possible in the region. We can't do it as quickly as it should. This picture shows the calculation of the noise distribution that we determined and published during the process of planning to show people what will expect them. And the new runway here, it mainly goes over Offenbach. That was the central point. And then very quickly the idea came, why don't we fly that way? When I showed that picture, another presentation, just as you see the photographer here, it was photographed, and the next day it was stated that I said that the route path, the flight path should go here, and that would affect the population there. No, that's not what I do. I only show you some principles. I'm here as head of the DLR, and I show you principles. The flight path look different, the routes look different, and there's much more annoyment when you see that. As for politicians, it's really difficult that more and more people are annoyed. Although from a regional point of view, it might be reasonable. We heard that there are different approach and departure procedures, also steeper approaches. If I have a slope like this, the final slope, final gliding approach, in the proximity area, the effect won't be that strong, and the same goes for steeper departures. There are also pros and cons here. Steeper departures need more propulsion, and close by it becomes more noisy again. So as with many other disciplines, there are not only positive effects, we also have to consider negative effects as well. The engines, that has always been in the foreground, and in the engine we can do a lot. If you read the paper today, they talk about the output, the chevron nozzle, but we can do even more. Within the engines, we can also do active noise abatement. Here at the intake, we can do something, and this is what we as DLR really carry out a lot. We show you a chevron nozzle here. The engine is in the center, although it's no longer the only relevant producer of noise, because the engines have become very quiet because there is a good bypass ratio now. And if we take a look into an engine, especially the front area is very interesting for us. In the front area, you can install some effects by producing some holes and insulate the noise, and then there are local turbulences, and hopefully then it becomes quieter. We call it the fluting effect. Like with the flute, you produce the sound with a little plate. Also here, this fluting effect can be produced in such a way. With conventional methods, we can also silence it, but in the higher frequency range, with the fluting effect, we can reach more, or with active blowing in of air, you can do a lot. So it seems to be as if this red line would be the best what we can do over a broad frequency range. I also mentioned active noise reduction, and that's a simple picture. That's a Bose loudspeaker or a Sennheiser loudspeaker. Here you can measure the sound, and a counter sound is produced, or a trigger signal is produced, and that's a technology we could use for the engine. We take up the sound with a microphone, and we produce a counter sound so that they balance. With the Bose loudspeakers, because of frequencies, you can do it easily. With the engine, all right, you have so many different frequencies that it's not so easy, and the effect is not so good, but it has an effect, and we want to develop it further. Minister Boddenberg mentioned the turbulence generator, and we would recommend that for the parasitic noise resources. It's this sweet little part, you know, it says 2002 here. It was developed already in 2002. The effect is very simple. Like a bottle, you know, if you blow over a bottle, you can do that, and then you produce beautiful sounds. And if you have a turbulence generator in front, then it's gone. Just to show it to you, I hope it works. I just play it to you. First without generator, and then with generator.
Also wenn Sie was gehört haben, dann haben
If you heard something, you just have heard this effect that one frequency was not there. Okay, it's not silent, it's not extremely quiet, but it's an improvement. And such effects can be produced with different areas. There are always open pipes and tubes, and there's always this bottle effect when blowing over it, that some sound is produced. You have it with the landing gear a lot. And therefore, the development of new landing gears is looked at a lot. As a layperson and as a construction engineer, I'm still a layperson. Okay, you would say, just line it or clad it. But there's always a but. But I come back to this but later on. I would like to show it to you. This lining, as you see it here, reduces already up to 8 decibel. With the landing gear. So there is a clear effect. One effect, once you have seen a landing plane, normally the landing gears are like this for landing. That's good, but not so good for noise. And therefore the positioning of the wheels is also a good point. This would be the optimal situation, but we also have brakes here, and the brakes become really hot. And therefore it's not so easy to find a solution as it might look here on that picture. So you have to cool it, have to organize cooling, so that the most important function of the landing gear, landing and braking, must not be forgotten. And then there are also these little details, many of them. Here you can see the flaps and slats, and they have gaps everywhere, and they produce noise easily. And if probably instead of the gap you install a brush, then all of a sudden there is no noise. So that's a little effect, but with a relevant result. So these are little things, different inclinations of the landing gear, different brush designs, different issues, how you can adapt the slats to produce local noise only to a small extent, and all these little openings have to be looked at. We as researchers, let's do it across the board. Let's design a totally new plane, might look like that. The engines at the top are screened also laterally. It looks greatly. This only shows you the wind speed at the different places and spots here. There are disadvantages here for the maintenance of the engine. Not so funny if it's at the top there, but we shouldn't be stopped by ideas like that. And there were planes like that, the VFV 614. On the 5th of April 1971, it had their rollout in Bremen. 20 of them were produced. We bought one, the DLR, bought one. Until last year, we even flew it. And if you take a closer look, you can see something else here. The engine didn't have any reverse thrust, because with the reverse thrust, there are some discussions. Of course, it's a question of safety, whether I can really use brakes safely under bad weather conditions, but there was no reverse thrust, and therefore that discussion would not have taken place. We used that aircraft to simulate larger ones mainly, so we also use it for other research purposes, not only noise. In our fleet, we also have an Airbus 320, and here we also test a lot of things, like the auxiliary power unit might be replaced by a fuel cell. Well, that would make it quieter at all aircrafts where you need an auxiliary power unit, an APU, and the electrical energy generated can not only be used for air conditioning and other things, but also while rolling on the runway, we can drive the wheels. For simplicity's sake, we did it on the rear, at the front. There is no much burden on it if it's uphill, and there is no the effect is not so good, but with the main landing gear it's different. But picture is not so clear. That will come. I thought it would come. No, sorry, so let's just go on. We just showed that the noise landing gear can be driven by a fuel cell and can drive the whole plane. Of course, we are also talking about electrical drive systems, and we built a plane with a fuel cell and a hydrogen tank and an electrical motor, and there are different concepts. Also the question whether the main engines should be rather in the rear, sound insulated, and use electrical power to bring it to the front for the wings, and also reduce noise as a result. Our researchers have thought further. They have thought of aircrafts like that, and the effect is that the engines are above the fuselage, which makes it silent, and we don't have all these flaps and slats. It's more silent, and the passenger compartment can also be used for further thrust, for further lift. It's highly interesting. There are disadvantages as well. Just check it. Go to a counter in the airport and find out how many people want to sit at the windows. That's a finite problem, because there not that many windows. I rather sit at the aisle, but I don't share that with many others. Now, my conclusion. Both existing possibilities need to be used and tapped, but we also have to be open for new ideas and don't reject them directly because they seem to be insane. We have to do everything possible to upgrade existing technologies to reduce noise, and every aspect of a plane needs to be looked at, whether it's the engines, whether it's turbulences for landing gears, or what have you. Of course, not only technologies, limits of technologies need to be seen, but also what we heard about approvals needs to be considered, because safety is really also important for the future. But we need revolutions as well, and for that we need to take a holistic approach, and I would be a bad boss of the DLR. Probably I'm a bad one, but I would be even worse if I didn't regard research as a central point of our activities. There remains the question, however, who is the driving force? Responsibility of the different stakeholders? Do we need incentives, financial incentives, positive, negative ones? Or is it that the fact that the number of aircraft movements will grow is a driving force already, and that limits of noise tolerance are reached already? Is that enough for a driver to do something here? Or is it that we always look to politicians, that they have to rule it? If so, then we should write a letter together to Berlin, because all the politicians are sitting there today. Before I end, I would like to show you a last picture as an image of future. And at the end of the short clip, you might understand how I see the future.
So, meine Damen und Herren.
Ladies and gentlemen, now it's your chance to discuss with me.
You have the possibility to ask me questions or give me any dirty comment, please. I know you want to go to lunch, but you may have time for a question. There is none. So, da ist einer.
Hier ist one. Helmut Breidenbach, Bundesvereinigung gegen Fluglärm. Herr Wörner,
Association Against Aircraft Noise. Despite my respect to your research center, I have one request. It's about the effect, the impact of technical progress. You have shown to us what's possible, and we heard that there might be a reduction by 10 to 12 decibel. But you said that it would take 20 years and you need another quantum leap. Well, you should tell us always in those cases, because in Berlin we have a problem. Politicians who are ignorant, and we really have to tell them that this is not available tomorrow. I answer in German. You are right. And at the same time, I would also offer an argument against. If we say it takes X, Y, Z years, more than 20, then quickly there might be the feeling, all right, we can't do anything at the time being. And that's something I'm afraid of. I think we need research and development activities now. We need industry to test certain things, to be prepared to test certain things. And then we have to see what we can achieve in what period of time. It's quite clear that we still have aircraft from the 60s flying around. I know that. And even if tomorrow every new aircraft is quieter by 10 or 12 decibel, we would not have reduced total noise by the same extent. I know about that. But as head of a research center, I really have to say that I don't want to stop technological development. Absolutely correct. It's not that the consequence should be that you don't do anything, but you should know, you should be aware of the fact that the improvement will take 20, 30 years. So politicians have the chance to wait for quieter aircrafts, and that's the program they have. You know, you have to make very clear that also in the sense of our approach, that cannot be the sole solution. Of course, every technological progress in between should be used better, faster, more precise, but this doesn't solve the problem at all. And I have the feeling with all the governments that we had before, they only wait for quieter aircraft, and that's the danger. All right. I just jump into my other hat as member of the board Forum Flughafen und Region. We are not waiting for the future in 20, 30 years' time, as Mr. Biestmann and Mr. Ockel said it. We do now what we can do now, together with Lufthansa, Air Berlin, and the other airliners, and the Frankfurt airport. We try to introduce measures that produce effect already today. And I was happy to hear that the fleet renewal with Lufthansa also has clearly positioned in this direction. And Mr. Crotty told the press that he is massively in favor of different noise reduction measures. I continue to say we need to do our utmost and everything possible, and this is what we want to do in the future as well. My name is Wolfgang Hoffmann, Federal Association Against Air Noise. One example why it won't work as we would like to have it. The MDL-11 is an aircraft that is relatively old, but as McDonnell Douglas disappeared. It was taken over by Boeing, and there was a situation where it was sold at the end of the 90s. So this type of aircraft that is quite noisy will be around for another 15 years at least. And the airlines tell us, well, we have a modern fleet, the B-77, which was meant to be the replacement aircraft and would be welcomed by us, is not much older, but much quieter, or less noisy, I'd rather put. And despite that, this aircraft is only introduced with a lot of hesitance. Well, let me answer cynically. Let me give you the following advice. Go down to the road and watch into the cars driving by. How many of them have a green, yellow, or red button, environment protection? Well, the individual might say, my car doesn't change the situation. And that's the same for the noise. And this is my function as moderator again. I think we have to consider both sides. The airline companies, of course, they have to be efficient in terms of business. And that might lead to the situation that they say, I can't exchange my entire fleet right now. That might be. But I don't know where they want to go. And therefore, I will continue to work in the direction that existing aircrafts become quieter. The A320 will be replaced very soon, so we can leave it as it is. No, we also try to improve the A320. And Lufthansa has carried that out together with the certificates with Airbus. Okay. The existing aircraft, I tried to mention that in my summary. Continue to work on what we have, but not forget about the future and future possibilities. And there was another remark there and over there, and then I, as a moderator, have to stop you. Thomas, you're head of the Air Noise Commission. The questions that were mentioned before wanted to show that you probably hid in your presentation that you are waiting for improvement and technological improvement in the future. But well, I understood from your presentation that you said we are not waiting. The instrument of the upper noise limit is an appropriate instrument to give the right incentives to use quieter aircrafts and demand them in the market. And I think you really have described it well. But my question now goes in the following direction. As we have an international conference, and I know that there are colleagues of the Airport Regions Conference here, and the question is, your contacts that you definitely also have at the European level or global level. What about other countries? Do they want to achieve noise reductions and upper limits for noise, etc.? Are there positive reactions, or is it that in other countries it's not developed that much? Thank you very much for that. Probably I was not so clear. I hope that this picture was shown to you once again. I tried to say it with this picture. I tried to really explain to you that now we have to start. It's a self-obligation of industries somehow. And if we went along that way, we don't do anything, and in 45 years we reach the 35%. That's nonsense, and we can't do it that way either. That wouldn't work out, and therefore I showed you the straight line, and this line means a lot of efforts, and only then we can produce this result. That was my attempt. Thank you very much that you helped me with the pictures. What I showed you here, that's European. That's European. At the European level, it has been agreed. I have to admit, however, that at the European level, not all countries approach this subject in the same way as we might do it here. But that's no reason to fall back. We could also say, all right, well, what happens in Sicily at petrol stations, with oil that is dripping there, should be the basis for Germany. That's the same European Union. No, we mustn't do that. But many countries have attentively followed what we have done here in Frankfurt. First step, some say, also with the energy change, say, let's wait and see how it will work out. And others say, you're on the right way. So there is everything there. And some wait for competitive edge by saying, all right, we have the hub elsewhere, not Frankfurt and Munich. All right, there are all the three opinions around. There is tough competition. There are those that support us and are advocates. And there is the group of people who say, let's do it together, Europe and the world. My name is Schmidt. I've got one question to you. You showed before how in the area of technological development you want to position yourself. Noise abatement definitely is state of the art. The ICAO, with the balance approach, determines that they are the institution that determines the state of the art. In how far can you cooperate with them? Or are you cooperating already with them in order to further develop state of the art, improve it? Well, I would like to say it as follows. I'm never terrified by rules that are made by people at some point in time, and then I say, as this rule has been written, I have to adhere to it. If we did do it that way, you know, we would still live in caves. We would never ever had gone to the neighborhood. We'd never gone to Americas. Well, you know, I think progress needs people who trigger it. And if we have to adjust rules and regulations, then we have to do it. Just to say there are rules and regulations probably for the Bible, that's correct, but not with other documents. You can change them. Of course, the ICAO has really focused on safety a lot, and that's really what is best for all of us. I mean, safety is top priority no matter what noise considerations are made. But noise plays an important role in determining details. I think this is globally accepted in the meantime. And of course, we are cooperating closely also with the FAA via NASA, with which we work together. I mean, they're not so famous for their aircraft research, although they have double the budget for it. They're rather famous for airspace. But we also work together with them closely, and also with ICAO, we really work together.